Welcome to section 8.4. We're now going to transition into multiplying and dividing radicals. Now, as we do this, please realize we're not going to do the multiplication like we did in 8.3 where we only had one radical times another radical. Instead, to kind of show you, let's just jump into an example. In this case, I have a radical times an entire binomial. So I have two terms, so I have square roots. Now, the simple fact that there's square roots doesn't change there's properties just of square roots that we just have to use. But the same idea here is just, again, it's a distribution property. So the distribution property of multiplying is going to come back over and over again. I would recommend before I even start on this example, go back to chapter 5. Remind yourself how to multiply all the different cases so that you feel comfortable multiplying out polynomials, and that will make this feel that much better. All right, so let's get to this particular example. First, I can distribute, so I can just multiply x times the square root of 7, and then I can go square root of 7 times square root of 10. Well, that's going to be x square root of 7 times the square root of 70, because remember we multiply what's underneath. Now, a quick comment about notation. Notice we always put whatever is not a radical in front of the radical part. Even if it's x, it still goes in front of the number. This is just so there's not confusion, because sometimes people draw this line too long and other things like that. So it's just to make it clear as to what's not in the radical and what is. So x squared of 7. Now before we'd walk away from this, we have to ask, can I simplify? In this case I can't, because the square root of 7. 7's a prime number, there's no perfect squares in there. And again, 70, the only numbers that go in there are 2, 10, 5, and 7. So none of those really combine to get me in a situation that is going to be a perfect square. So we can just leave it as that and move on. So with that in mind, I want you to try to multiply together all of this. So distribute and multiply together. Go ahead and pause the video and do that. Welcome back. Well, hopefully, again, I have negative square root of x times the square root of x. So I just multiply those. Then I notice I get positive 3. That's because I have a negative. The 3 can kind of scoot out in front because it's not a square root, and I got square root of x and square root of k. Now we can multiply those together, and notice I get the negative square root of x squared plus 3 square root of xk. But the square root of x squared is x, so it's negative x plus 3 square root of xk. Now you may be asking the question of, why did I have absolute values? Because doesn't x have to be a positive number? And no, the reason I can get away is just because this is an original. In the original problem, x is underneath the square root. Well, the only way x is underneath the square is x is a non-negative number. Therefore, I can just go ahead and drop the absolute value. So because I just have x in my original situation, I'm okay. Well, let's try multiply a cube root now. So same exact idea, it's just now a cube root. So I want you to pause the video and multiply these together using distribution. Welcome back. As we do that again, we can distribute to each of the terms. Now, when you do that, you can notice, well, this is going to give me the cube root of y cubed. And over here, I get the cube root of 7y, or y times 7. It's just how we usually write it. Now, don't drop your roots. It's going to be important because now we can simplify the cube root. That's just going to give me y, and minus the cube root of 7y. So again, we can't simplify any further because this 7 and y have nothing in common. So we just go ahead and get to this point in time and we stop. Well, I want you to take a moment, and now what happens if I have a radical binomial times a radical binomial? So how would you multiply those together? Go ahead and pause the video and try to distribute or multiply them together. Welcome back. As you did this, again, I can take the the square root of x plus the square root of y and multiply it to each of the terms in the first one. That's where we get this. Now we're going to distribute that in, so I have the square root of x times each of these, and minus the square root of y, and that's why this turns out to be minus, times each of those. Now we can multiply each one of those specific terms, so I get x squared plus the square root of xy minus the square root of xy minus y squared, square root of y squared. Well, notice this is just going to give me x. These two terms are going to cancel out. There's nothing left. And this will give me minus this y, because it's square root of y squared is y, which leaves us with x minus y. Again, we didn't have to assume that any of our variables were non-negative because originally they were underneath the square roots all by themselves, which meant they had to be non-negative or else our original radical would have had a slight problem. Okay, so take this, and now I want you to try multiplying that out. Go ahead. Well, hopefully the first thing you remembered is to square things really means I'm going to multiply it by itself. If you distributed the squared to each of these terms, remember you can't do that because there's an addition sign in the middle. So you have to rewrite it and multiply it out. If you didn't, pause the video and multiply it out. If you did do this, well, then you redistribute. Again, I'm going to just take this and multiply it to each term. And so I end up with the square root of 5 times square root of 5, square root of 5 times square root of 6, etc., 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 which multiplies out to square root of 25 plus the square root of 30 plus the square root of 30 plus the square root of 36. Well, the square root of 25 is 5. And then the square root of 30 plus the square root of 30 is 2 square root of 30. And I can't do anything more because 30 doesn't have any perfect squares in it. And 36, well, that's just 6. We can still combine like terms because 6 and 5 don't have any square roots. So we get 11 plus 2 square root of 30. So this idea about how we actually multiply them together hopefully is helping you kind of start seeing how all this plays together. All right, one last example for this multiplication process. I want you to go ahead and pause the video and multiply this all the way out. Go ahead. Well, hopefully you again use distribution, and we can distribute the second binomial to everything. Again, distribute, so I have 2 times 3, and then I have 2 times the square root of 2, and then I have 3 times 5 square root of 5, and 5 square root of 5 times 2 square root of 2, which is going to give me 6, minus 4 square root of 2, minus 15 square root of 5, and minus square root of 10. Now, once you get to this point in time, this goes back to the addition subtraction from the last chapter. So looking at this, there's nothing I can simplify. I can't simplify, I can't simplify, I can't simplify. And they have nothing in common because none of the radicands are the same. So therefore, we're done. That's our final answer. All right, that wraps up the first part of this video. Please remember to go and watch the second part of the video about dividing and rationalizing the denominator.